This procedure covers reballing of BGA components. The minimum skill level needed to complete this procedure reliably is expert. The conformance level reached when this procedure is completed properly is high. See the web page for a list of the tools and materials required to complete this procedure. The procedures follow. Procedure: touchless ball removal. This BGA component deball process dissolves and flushes away the existing solder balls, leaving a flat surface on each of the BGA component solder pads. Step 1. Ensure the BGA components to be processed meet the requirements for acceptable moisture level. Note: for information on baking and moisture level control, see 2.5 baking and preheating. Step 2. If the BGA components are supplied on tape and reel, a matrix tray or custom holding fixture will be required. Step 3. Set up the robotic deball system with the proper process parameters including solder immersion depth, dwell times, insertion and extraction speeds, solder temperature, and other settings. Note: refer to the component data sheet for guidelines regarding component peak temperatures specifications and other process parameters. Step 4. Load the BGA components onto the fixture or matrix tray and place into the robotic BGA deball system. Step 5. Activate the robotic machine process cycle. Step 6. Pick up a row of components from the matrix tray using a multi-head vacuum pickup. Step 7. Apply flux to the existing solder balls. Step 8. Remove the excess flux using an air knife. Step 9. Run the components through a programmed preheat stage to activate the flux. Step 10. Remove the unwanted solder balls using a dynamic solder wave. Step 11. Run the components through a filtered hot water rinse to remove the flux residues. Step 12. Dry the components using an air knife. Step 13. Return the deballed BGA components to their original position in the matrix tray. Step 14. Visually inspect the BGA component appearance, cleanliness and condition. Check the solder pads for flatness and inspect the body of the BGA component for abnormalities. Procedure: reflow oven attachment. Step 1. Apply tacky flux to the flat BGA component pads using a brush. Flux should be evenly applied across the entire BGA pad surface. Use minimal flux needed to fully cover the surface. Remove any excess flux. Step 2. Place the BGA components into a fixture and cover with a matching stencil. Check to ensure the alignment is correct. Step 3. Place a quantity of the appropriate size solder spheres onto the fixture and use a cleaning brush to distribute the solder spheres so they fill all the open apertures in the BGA component stencil. Check to be sure all the apertures are filled with only one solder sphere. Tilt the fixture and pour the excess solder spheres into a collection container for reuse. Note: avoid overloading the solder stencil with excess solder spheres as they may wedge under the stencil. This will make lifting the stencil to remove any excess solder spheres difficult. Step 4. Set up the reflow oven with the proper profile and run the oven for 5 minutes to ensure the reflow zone temperatures are stable. Note: if a profile has not been defined, a profile will need to be created. Step 5. Run the BGA fixture and BGA components through the reflow oven. As the fixture moves through the oven, the fixture and components will go through the required preheat, reflow and cooling cycles. Step 6. When the fixture and components emerge from the reflow oven, use gloves to remove the fixture and place on a flat surface. Allow the fixture and components to cool for 1 minute to ensure package thermal stability prior to removing the BGA component from the fixture. Step 7. Visually inspect the BGA component balls for proper alignment and appearance. Step 8. Clean the BGA components in approved cleaning solution. Step 9. Inspect the body of the BGA components for abnormalities. Step 10. Inspect the BGA components for cleanliness.